Without these inventions, Rome would never have built an empire. The Roman Empire conquered half the world, not only thanks to the bravery of its legionnaires. The main secret of its victories was revolutionary weapons that gave the Romans a decisive advantage over any opponents. While the barbarians fought with primitive swords and clubs, Roman engineers created deadly machines. These inventions changed the very concept of warfare and laid the foundations for military affairs for thousands of years to come. Today we will talk about 7 types of weapons without which the great Roman Empire would not have existed. Watch until the end. The last invention was so powerful that even the Romans themselves were afraid to use it. The first weapon that truly transformed the history of warfare was undoubtedly the Roman gladius, a short sword that proved to be a real revolution in tactical weaponry. Derived from Celtic Barian models, it was officially adopted by the Romans around the beginning of the 2nd century BC and quickly replaced the longer and outdated swords that had been used previously. The gladius had a blade length of about 60-75 centimeters and a width of about 5 centimeters at the base. Thanks to this design, short, heavy at the hilt, and sharply pointed, it was ideally suited for piercing blows in close combat. This feature made it incredibly deadly in the hands of a disciplined legionnaire. The secret of the gladius design was that it was created specifically for stabbing attacks, rather than for wide slashing blows. The long swords of other peoples required swing in space, while the gladius allowed for quick and accurate stabs, even in close formation. The sharp cone at the end of the blade easily pierced the armor and shields of the time, leaving the enemy with very little chance of defense. The metallurgy of the gladius was advanced for its time. Roman blacksmiths used forging techniques that gave the blade both flexibility and hardness. The central part of the sword was made softer for resistance to stress, and the cutting edges were hardened, which ensured durability and sharpness. This technology made the gladius a reliable weapon capable of withstanding numerous battles. The manufacture of a gladius took a long time and required precision. The iron and steel blank was forged repeatedly. Then the craftsman achieved a uniform blade structure so that the metal had no weak spots. The final hardening was carried out under strictly defined conditions, which ensured strength and preserved the sharpness of the blade even with prolonged use. The metal pommel served as a counterweight to the blade, allowing the legionnaire to hold the weapon confidently and deliver quick, accurate strikes without unnecessary effort. The gladius scabbard was a separate engineering solution. It was made of wood, covered with leather, and reinforced with metal plates. The fastening system allowed the sword to be carried on the right side, leaving the left hand free for the shield. This combination ensured perfect combat readiness. The gladius could be drawn in a second and immediately used in an attack. The tactics of fighting with a gladius were radically different from the usual methods of other peoples. Roman legionaries did not swing their swords, but delivered short stabbing blows from behind their large shields. This technique required minimal space for maneuvering and was deadly in close formation. Enemies accustomed to fighting with long swings simply did not have time to react to the quick and accurate thrusts. Training in the use of the gladius was one of the key parts of a Roman soldier's training. Recruits trained for months on wooden dummies stuffed with straw, practicing each strike until it became automatic. Every thrust had to be precise and deadly, without unnecessary movements, because in battle, seconds decided life or death. The psychological effect of the gladius was no less significant than its physical characteristics. Barbarians accustomed to protracted duels and wide swings of swords were shocked by how quickly and effectively the Romans acted in formation. One precise thrust could end the fight before the enemy even realized what had happened. There were several varieties of the gladius, adapted to different conditions. The mace was an early version with an elongated tip designed to pierce armor. The Pompey was a later modification, shorter and with straight lines, ideal for quick strikes in close formation. The spada, which appeared later, was an elongated version, convenient for cavalry, and gradually replaced the gladius in the 3rd century AD. The mass production of gladiuses was an important achievement of the Roman military system. Tens of thousands of blades were stored in the empire's arsenals, which made it possible to arm new legions without delay and replenish losses after battles. Standardization of quality ensured that every soldier had the same level of weaponry, which also strengthened the army's combat effectiveness. The influence of the gladius on military art is enormous. Not only did it ensure Rome's military superiority for centuries, but it also became the prototype for many types of weapons in future eras. The principle of a short stabbing sword was later borrowed by European armies, and modern combat knives are still made according to the same basic principles as the ancient Roman gladius. The second revolutionary weapon of the Romans was the pilum, a heavy javelin that changed the tactics of infantry battles. Unlike the simple throwing spears known to other peoples, the pilum was a true engineering masterpiece. This weapon not only struck the enemy from a distance, but also undermined the enemy's formation before it came to hand-to-hand combat. This was its value. The legionaries entered the battle with a weakened and demoralized enemy. The design of the pilum was striking in its simplicity and thoughtfulness. Its total length was about 2 meters. Approximately 1.2 meters was taken up by the wooden shaft, and another 80 centimeters by the iron part with a sharp tip. However, the main trick was not in its size, but in the way it was attached. The narrow metal neck, only a few millimeters in diameter, was specially made to be soft and flexible. It bent on impact, making the weapon virtually disposable and extremely inconvenient for the enemy. When the pilum pierced the enemy's shield, its iron neck bent under the weight of the shaft. It was almost impossible to pull such a dart out of the shield. It either got stuck forever, or the shield became unusable for further combat. Thus, a single throw turned the enemy's defensive equipment into a heavy and useless burden, forcing the warrior to drop it right on the battlefield. Throwing a pilum required special training. The Romans threw javelins not for distance but for maximum effectiveness. The optimal distance was considered to be 15 to 20 meters. It was at this distance that the pilum pierced the shield and struck the enemy through their armor. Unlike light spears, which could be thrown at the enemy from a distance, the pilum was intended for a close-range destructive volley preceding a sword attack. Each legionnaire carried 2 types of pilum, light and heavy. The light one weighed about 1.5 kilograms and was suitable for throwing at long distances, while the heavy one, weighing more than 2 kilograms, was intended for close-range throwing with maximum penetrating power. This system made the weapon versatile. Soldiers could first hurl light javelins at the enemy, and then heavy ones, which literally broke through the defenses. The Romans perfected the tactics of using the pilum. Before the start of hand-to-hand combat, the legionaries fired a volley of javelins. Thousands of pilums rained down on the dense ranks of the enemy like a deadly storm. Shields were pierced and rendered useless, and many soldiers were seriously wounded even before closing in. At this point, the Romans closed ranks and advanced with their gladiuses, encountering a disorganized enemy deprived of protection and confidence. The effect was not only physical, but also psychological. Warriors accustomed to relying on sturdy shields were shocked to see their main means of defense become a burden. Under the blows of the pilums, their belief in invincibility collapsed, their morale fell, and their resistance weakened. The production of pilums was streamlined in Roman arsenals. Standardization of sizes and designs allowed them to be mass-produced, which ensured a constant supply of weapons for the legions. Usually, each legionnaire had several pilums, including spares, so that the army could conduct long campaigns without interruption. There were different modifications of the pilum. Some had weighted tips for piercing particularly strong armor, while others were equipped with serrated blades that left lacerated wounds. There were also versions with a more durable neck, specially designed to bend when struck. This variety made the weapon a flexible tool that could be adapted to different combat conditions. Archaeological finds confirm the widespread use of pilums. Thousands of iron tips are regularly found at ancient battle sites. Historical sources mention that, in the Battle of Alesia alone, the Romans threw tens and possibly hundreds of thousands of javelins, creating an impenetrable wall of iron falling on the heads of their opponents. The significance of the pilum in military history cannot be overestimated. It became the prototype of a weapon that could not be used against its creators and embodied the principle of a one-time strike that made the enemy vulnerable. This idea, which appeared in antiquity, survived the centuries and was applied in a modified form in military technology, even in modern times, when weapons with a similar concept were created. Thus, the pilum was not just a spear, It was a tool of tactical superiority that made the Roman army even more invincible. It broke formations, deprived enemies of their defenses, undermined their confidence, and paved the way to victory. The third weapon of the Romans was the scutum, a huge rectangular shield that turned legionnaires into mobile fortresses. Unlike the familiar round or oval shields of other peoples, the scutum was an entire defense system around which all Roman tactics were built. It performed several functions at once. It provided reliable defense, served as a weapon of attack, and allowed the creation of unique formations that made the Roman army virtually invincible. The size of the scutum inspired respect and fear. It was approximately 120 centimeters high and 75 centimeters wide. Such a shield covered the soldier from head to knee and left a minimum of vulnerable areas. Its special convex shape not only better deflected blows, but also distributed force across the entire surface, reducing the likelihood of penetration. Unlike the simple flat shields of their enemies, the scutum was designed for combat in close formation, where every little detail determined the outcome of the battle. The shield's design was the result of painstaking engineering work. The base was made of 3 layers of thin wooden slats laid crosswise and glued together. This technique gave the shield special strength and at the same time made it relatively light, weighing about 6 kilograms. The wood was covered with durable leather, which protected the surface from moisture and impact. Metal edging ran around the edges to prevent splitting, and a massive umbo was attached in the center, a convex metal piece that served as both protection and a weapon. The handle was positioned horizontally and located directly behind the umbo. This made it easy to hold the shield and use it as a battering ram if necessary. A soldier could hold the scutum forward, covering himself completely, and then push the enemy sharply, knocking him off his feet. A direct blow from the umbo could cause serious damage, from broken ribs to head injuries. The lower edge of the shield was also used in battle. It was used to strike the legs of opponents, causing them to lose their balance. Thus, the scutum was not only a means of protection, but also a full-fledged weapon. The shields were painted in bright colors and decorated with the symbols of the legions. They depicted eagles, lightning bolts, divine signs, and the names of the units. This coloring had a double effect. On the one hand, it strengthened the fighting spirit of the Romans themselves, creating a sense of belonging to a single army. On the other hand, it frightened enemies when tens of thousands of identical shields formed a solid red or gold wall, glistening in the sun. The tactics of using the scutum were unique. Each legionnaire held the shield with his left hand, covering his body from shoulder to knee, and with his right hand he struck with a gladius through specially formed gaps. In battle, this turned the Romans into a living mechanism. A single solid line of shields protected the formation, while the blades protruding from behind them delivered deadly blows. The scutum formation, known as the tortoise, testudo, brought the greatest fame. Legionnaires in closed ranks raised their shields not only in front and on the sides, but also above their heads, forming an almost impenetrable dome. Under such protection, the Romans could approach fortresses closely without fear of arrows, stones, or spears. To their enemies, this moving fortress seemed like a miracle of military technology, impossible to pierce, break, or stop. Training in the use of the scutum began from the first days of service in the legion. Recruits were accustomed to the weight of the shield and trained in the correct stance and movement with it. To develop strength and endurance, weighted training shields were used, which were heavier than combat shields. Soldiers learned to strike with the umbo, take cover in formation, and act in sync with their comrades. All this turned the legion into a perfectly coordinated mechanism. The production of scutums required skill and time. Experienced craftsmen selected the wood, glued the layers, reinforced the edges with metal, covered them with leather, and painted the surface. Each shield was the result of several weeks of work. At the same time, hundreds and thousands of identical scutums were created in the arsenals, so that each legionnaire had reliable protection. Caring for the scutum was the responsibility of every soldier. The shields were regularly oiled to prevent the leather from drying out and cracking. Fastenings were tightened, damage was repaired immediately, and the paintwork was renewed before campaigns. Losing a shield was considered a serious offense. It was as important as a sword, because without it, a legionnaire became vulnerable. The evolution of the scutum went hand in hand with changes in Roman tactics. The first versions were oval-shaped and lighter, which allowed for greater freedom of movement. Later, when the army focused on dense formations and defensive power, the shields became rectangular and more massive. Smaller round versions were created for the cavalry, which were convenient in the saddle. The scutum had a huge impact on military history. It became a model for many armies of antiquity and the Middle Ages. Large rectangular shields were used by knights and infantry in Europe, and modern police shields used to disperse riots still follow the same principles of protection and organization as the legendary Roman scutum. Thus, the scutum was not just a shield, it was the foundation of the Roman military machine, a symbol of discipline and the strength of the legions. It transformed soldiers into a single, unshakable formation in which each felt part of a great army, while enemies faced a mobile fortress that was almost impossible to break. The fourth revolutionary weapon of the Romans was the ballista, a torsion-based throwing machine that in many ways became the prototype for all subsequent artillery. For its time, it was a weapon of fantastic power and accuracy. It could hit targets at a distance of up to half a kilometer, and its accuracy amazed contemporaries. Hitting a single person or even a specific commander was not a coincidence, but a completely expected result. That is why the ballista is often compared to the sniper rifle of antiquity. Its principle of operation was based on the energy of twisted animal tendons or bundles of hair, which were used as a kind of spring. Two torsion springs, fixed horizontally in a massive frame, accumulated enormous power. When the levers were pulled, this force was transferred to the bowstring and then released at the moment of firing, giving the arrow or stone projectile tremendous speed. This system was significantly more powerful than any bow or crossbow of the time, and the idea of using twisted cords proved so successful that torsion machines were used for over 1,000 years. The design of the ballista was a complex engineering structure. A wooden frame held the metal parts and torsion springs, levers provided tension, and a system of blocks and gates allowed the machine to be loaded relatively quickly. The work required high precision. If the force of the torsion springs was distributed unevenly, the ballista could shoot crookedly or break altogether. It took weeks to build a single machine and required the participation of a whole group of specialists, carpenters, blacksmiths, and rope makers. The ballista was not just a weapon, but a true work of engineering art. The projectiles for the ballista were varied and selected for a specific task. The most common were long arrows, reaching a meter or more in length. Fired at tremendous speed, they pierced shields and armor and struck enemies at a distance of hundreds of meters. But ballistae could also use stone projectiles weighing up to several dozen kilograms, capable of destroying walls, towers, and fortifications. There were also incendiary projectiles, arrows with burning tips, which were used to set fire to wooden structures or enemy siege engines. The accuracy of the ballista impressed even allies. Experienced calculations could accurately hit targets the size of a person at a distance of hundreds of meters. There is evidence that during sieges, Roman commanders deliberately ordered ballistae to be aimed at enemy commanders, officers, and standard bearers. The loss of a leader at the beginning of a battle caused chaos, destroyed morale, and sometimes decided the outcome of the entire battle. The ballista's rate of fire was approximately 1 to 2 shots per minute. This was significantly slower than that of ordinary archers, but it was compensated for by its incredible power and range. In terms of effectiveness, one ballista could replace a dozen or more archers. At the same time, several dozen such machines, acting simultaneously, turned the battlefield or the walls of a fortress into a real hell for the enemy. There were several types of ballistae. Lightweight portable models called scorpions weighed about 50 kilograms and could be set up directly on the battlefield. They were used for accurate shooting at enemies at medium range. Heavy siege ballistas weighed a ton or more. They were transported only in disassembled form and assembled under the walls of the fortress. Such machines fired stone projectiles and were used as siege artillery to destroy walls and towers. The ballista crew usually consisted of 3 or 4 people, each of whom performed a specific task. One warrior commanded, aimed, and chose the moment to fire. Another installed the projectile and cocked the mechanism. The rest brought ammunition, serviced the machine, and repaired parts as needed. Only the coordinated actions of the entire team allowed for uninterrupted firing. Training to operate the ballista took months. Soldiers studied the machine's design and learned to calculate distance, wind corrections, and elevation angles. They had to be able to load the machine quickly and safely and distribute the force correctly when tensioning the torsion springs so as not to damage the mechanism. Unlike individual weapons, the ballista required collective cooperation and discipline, which made it a weapon not only of strength, but also of organization. Transporting ballistas was a separate task. The machines were dismantled, transported in wagons, and reassembled at the battle site. Experienced soldiers could put it into combat position in half an hour to an hour, but it still required time, tools, and protective cover. That is why ballistas were usually used either in advance during the preparation of sieges or as a means of support in large battles. The tactical use of ballistas was diverse. In open field battles, they struck enemy ranks and commanders, disrupted formations, and suppressed morale. During sieges, ballistas broke down enemy walls and covered towers, created breaches, and mowed down defenders from the ramparts. In defensive battles, they controlled the approaches to the city or camp, preventing enemies from getting close. The production of ballistas was concentrated in specialized workshops, as their manufacture required not only materials, but also knowledge of mechanics and mathematics. The cost of a single machine was enormous, comparable to the annual salary of senior officers. Therefore, ballistas were literally worth their weight in gold, and each one became a strategic weapon capable of deciding the outcome of a campaign. The influence of the ballista on military affairs was truly enormous. It became the basis for the development of all siege and long-range technology in Europe and Asia. Torsion principles were used until the early Middle Ages, and later evolved into trebuchets, catapults, and the first cannons. It can be said that modern artillery has its origins in the Roman ballista, which first showed the world the power of long-range projectile weapons. Thus, the ballista was more than just a weapon. It became a symbol of Roman engineering genius and discipline, proving that technology can be just as decisive in war as the bravery of a warrior. And it was the ballista that paved the way for humanity to create artillery, which changed the course of history forever. The fifth weapon that changed warfare was the catapult, a heavy siege engine for throwing stone projectiles. It was a true weapon of mass destruction in ancient times, designed not for duels or individual strikes, but for the systematic destruction of fortresses and fortifications. For cities that considered their walls impregnable, the appearance of Roman catapults meant inevitable collapse. They turned defensive structures into piles of rubble and the morale of the defenders into ashes. Roman engineers inherited ideas from Greek prototypes, but significantly improved them. They strengthened the torsion mechanism, increased the size and power of the machines, introduced more reliable components, and developed a precision guidance system. Thanks to this, Roman catapults were transformed from crude throwing devices into formidable engineering weapons with unprecedented destructive power. The most powerful catapults could hurl stone projectiles weighing tens of kilograms up to 400 meters. The stones, flying at the speed of a whirlwind, pierced walls 2 meters thick, split towers, and covered gates. A single hit was enough to create a breach several meters wide, through which the legionnaires could rush to storm the fortress. Even if the walls remained standing, constant bombardment terrified the defenders and gradually depleted their strength. The catapult's design was a complex engineering structure. A wooden frame up to 4 meters high held giant torsion bars, twisted bundles of wires or fibers that stored energy. A system of levers and blocks allowed a machine weighing several tons to be cocked by the effort of 1 or 2 people. The entire device worked on the principle of accumulating and instantly releasing energy, which made each shot incredibly powerful. Ammunition for catapults was specially manufactured. Stone balls were carved from durable rocks such as granite or basalt. To increase their destructive power, they were given an uneven shape with sharp edges that would split walls upon impact. Some projectiles were hollow and filled with combustible mixtures. Such stones would explode on impact and cause fires inside the fortress. This made the catapult not only a weapon of destruction, but also a weapon of intimidation. The Romans constantly improved the accuracy of their catapults. Engineers developed devices for measuring angles and a targeting system. Special tables were created for wind and distance corrections. Experienced calculations could hit the gates of a fortress or a separate tower from a distance of several hundred meters. Sometimes commanders specifically ordered to fire at crowds of people, which caused enormous damage to the defenders. The psychological effect of catapults was no less important than the physical one. Huge boulders whistling through the air and crashing into the walls caused panic. The roar, clouds of dust, and collapsing towers all broke the will to resist. Many cities surrendered to the Romans even before the assault began, just seeing the rows of heavy catapults taking up positions. There were several types of throwing machines. Light onagers were used in the field to fire at troops and camps. Heavier designs were used during sieges to destroy walls. Ballistas and catapults worked in tandem. The former hit individual targets, while the latter destroyed fortifications. Later, even larger machines appeared, foreshadowing the medieval trebuchets. This variety allowed the Roman army to solve a wide range of tasks on the battlefield. Operating a catapult required a whole team. The crew consisted of 8 to 10 people. The commander of the machine was responsible for aiming and selecting targets, while other crew members loaded shells, pulled levers, checked torsion bars, and monitored the condition of the components. The work was hard and dangerous. If a mistake was made, the machine could break down or injure soldiers. Supplying the catapults with ammunition was a separate problem. Thousands of stone projectiles were needed for a long siege. For example, up to 500,000 kilograms of ammunition could be used up in a few months of siege. The stones were quarried in nearby quarries or delivered from many kilometers away, which required enormous effort. Setting up catapults in position was a real engineering challenge. They were installed on specially prepared platforms, reinforced with supports, and protected with shields from enemy arrows. Space was left between the catapults so that they would not interfere with each other and could fire continuously. Sometimes the machines were placed on embankments to increase the firing range and the angle of impact on the walls. Defensive methods were developed to counter catapults. Defenders built wooden barriers and covered the walls with wet skins to dampen the blows and prevent fires. Sometimes they dug underground passages to destroy the positions of siege engines or set them on fire from the inside. But in most cases, catapults still brought success to the attackers. The evolution of catapults continued for centuries. Later, Roman machines already included metal elements, more complex guidance mechanisms, and standardized parts. Some catapults were made collapsible and transported on wheels, which greatly accelerated their use in campaigns. Gradually, these machines became the basis of all siege artillery in antiquity and the Middle Ages. The influence of catapults on military affairs was enormous. They became a symbol of the power of Roman engineering and a prototype for future artillery. The principles laid down in Roman catapults were used until the appearance of the first powder cannons. Modern howitzers and cannons can be considered the direct descendants of these ancient machines, which first showed the world that long-range weapons could decide the outcome of a war. Thus, the catapult became a weapon that changed the very philosophy of warfare. It made walls vulnerable, cities defenseless, and the Roman legions truly invincible. The sixth weapon of the Romans was not a sharp blade or a throwing machine, but an engineering solution, the castra, a standardized mobile camp. It was this that turned any piece of land where the legion arrived into an impregnable fortress in just a few hours of work. The Romans understood that war is won not only in open combat, but also in how the army lives, moves, and defends itself on the march. The castra became the basis of this system. Every evening, after stopping after a march, the legion turned a field, plain, or even difficult terrain into a fortified camp. The dimensions were strictly standardized. For a full legion of 6,000 men, an area of approximately 600 by 400 meters was allocated. This space was sufficient not only for the soldiers, but also for their wagons, supplies, horses, and siege weapons. Thus, the legion received an autonomous fortified city that could be rebuilt again and again anywhere in the empire. The fortification of the castrum was built according to a single plan. First, a moat about 1.5 meters deep and up to 3 meters wide was dug. The earth from it was used to create a 2-meter-high rampart. A palisade of sharpened stakes was driven into the top. Together, this turned the camp into a full-fledged defensive structure capable of withstanding a sudden attack and stopping even numerically superior forces. For barbarians accustomed to open combat and quick raids, such fortifications became an insurmountable obstacle. The internal layout of the camp was a model of order. In the center was the praetorium, the commander's tent and headquarters, from where the army was commanded. The main streets radiated from the praetorium, dividing the camp into identical quarters for the sentries. The gates were located strictly in the center of each wall and were named according to their direction: main, rear, and side. This pattern was repeated every time, so that even if a legionnaire found himself in a foreign camp, he could easily find his way back to his place. The construction of the camp was organized down to the smallest detail. Each centuria had its own area of work. Some dug a moat, others built a palisade, and still others prepared the internal streets and set up tents. Everything happened quickly, without chaos or fuss. It took 2 to 3 hours to set up a full-fledged camp, and by evening the marching column had turned into a protected fortress city. The tools for these tasks were part of the standard equipment. Legionnaires carried not only weapons and armor, but also shovels, pickaxes, axes, and saws. In addition, the army had special engineering units that had more sophisticated tools and helped with particularly difficult tasks: reinforcing ramparts, building bridges, or installing siege engines. The logistics of the camp ensured the complete autonomy of the legion. Inside the camp, there were kitchens, workshops, warehouses for food and weapons, hospitals for the wounded, and stables for the cavalry. All this made the legion independent of local resources. The army could stay in one place for weeks without needing urgent supplies. The defensive power of the castrum significantly increased the strength of the legion. Even if the enemy outnumbered the Romans, they could not take the camp on the fly. Attempts to storm it ended in losses and demoralization. At the same time, the legionaries themselves felt safe and could rest easy, knowing that they were surrounded by a fortress built with their own hands. The standardization of the camp was a revolutionary solution. It simplified the management of troops, improved discipline, and created a sense of order and predictability. In any castrum, a legionnaire knew exactly where his comrades were, where the commander was, where the kitchens, warehouses, and hospital were. This greatly reduced the time needed for organization and increased the combat effectiveness of the army. Archaeological finds throughout Europe confirm the widespread use of such camps. Remains of Roman castra with identical layouts have been preserved in Britain, Germany, Gaul, and the Balkans. Some temporary camps eventually turned into permanent fortresses and then into cities. For example, many modern European cities grew out of former Roman camps. The tactical significance of the castra was enormous. In offensive campaigns, the camp served as a base for attacks and a command headquarters. In defensive operations, it became an impregnable refuge, holding back even vastly superior enemy forces. During sieges, the castra became a reliable position for placing catapults and ballistas, as well as a place of refuge for troops conducting long-term operations. The influence of the Roman system of field camps cannot be overestimated. The principles of rapid fortification, standardized planning, and autonomous supply are still used by armies around the world. Modern military bases and camps of mobile units actually repeat the Roman model, only using modern materials and technology. The evolution of the castra continued for centuries. In the early periods, camps were built entirely of wood and earth, but later stone walls and towers began to appear. In border areas, many camps became permanent fortifications. But whatever changes were made, the basic principles remained the same: order, standardization, and speed of construction. This is what made the castra one of Rome's most formidable invisible weapons. The seventh and perhaps most spectacular weapon of the Romans was the testudo, or turtle. This battle formation turned legionnaires into a living fortress capable of withstanding a barrage of arrows, javelins, and stones. Unlike the usual dense ranks of other armies, the tortoise was a revolutionary military solution that combined protection, mobility, and psychological effect. It became a symbol of the discipline of the Roman army and its ability to act as a single organism. The principle of the testudo was based on the use of large rectangular scutum shields, which served as a kind of armor plating. Soldiers closed their shields at the front, sides, and top, forming a dense protective frame. Inside this armor, legionnaires could safely advance, regardless of a rain of arrows or a hail of stones. No other army in antiquity knew of another formation that was as effective against projectiles. The tortoise formation required exceptional training and coordination. The front rows held their shields vertically, creating a wall that protected the entire formation from attacks from the front. The side rows covered the flanks. The rear and inner soldiers raised their shields above their heads, forming a roof that arrows and spears could not penetrate. It all resembled a mobile fortress, where each warrior protected not only himself, but also his neighbor. The size of the testudo varied depending on the task. A small turtle of 16-20 men was used for reconnaissance or a covert approach to the enemy. Larger formations consisting of 100-200 legionnaires could cover the advance of siege engines, ladders, or battering rams. In such cases, the tortoise resembled an iron dome under which death itself slowly approached the fortress. The protective properties of this formation were truly impressive. The closed shields formed a solid armor that neither arrows nor javelins could penetrate. Stones and logs thrown from the walls rolled down the sloping surfaces. Even boiling oil or resin, which the defenders of the fortresses often poured on the attackers, flowed down the roofs made of shields without causing serious harm to the legionnaires inside. The mobility of the testudo was, of course, limited. Its speed was about 3 kilometers per hour, slow but steady. However, this was enough to reach the fortifications and begin the assault. The formation could turn, move across rough terrain, and even climb slopes while maintaining its shape. This required iron discipline. Any violation of order turned the tortoise into a vulnerable target. The tactics for using the turtle were varied. In siege operations, the testudo was used to approach the gates and walls of fortresses under cover. In field battles, it allowed the army to overcome enemy archers or catapults. Sometimes the turtle was used for psychological pressure. Enemies saw a black mass of shields slowly approaching them, invulnerable to their weapons. This sight alone deprived them of confidence and undermined morale. The psychological effect of the testudo was enormous. Barbarians, accustomed to chaotic battles, could not understand how to fight this living fortress. To them, the legionaries in formation looked like a single invincible organism. Arrows and stones bouncing powerlessly off the shields instilled a sense of helplessness in their opponents, while the Romans, protected by the tortoise, moved step by step toward their goal. Training in the construction of the testudo began at the stage of preparing recruits. Legionnaires were taught to close their shields, move in unison, and maintain formation under any conditions. Training sessions lasted for hours, and it was only thanks to this level of discipline that the tortoise became possible. No other army of antiquity could replicate it with the same effectiveness, because it required not just training, but the complete submission of each soldier to the collective rhythm. The historical significance of the testudo cannot be overestimated. It became the embodiment of the principle that the strength of the Roman army lay not in individual valor, but in collective discipline and organization. The tortoise inspired many armies of the future to seek similar formations. Even modern police and military units use similar shield formations when suppressing mass riots or in street fighting. Thus, the testudo was not just a tactical maneuver. It was a weapon created by the very structure and discipline of the Roman army. It allowed the legionaries to become a single organism, a living wall, invulnerable to blows. And it was thanks to the tortoise that the Roman infantry was able to conquer cities and fortresses that seemed impregnable. The 7 types of Roman weapons we have examined changed not only the tactics of individual battles, but also the course of world history itself. Without these technical and engineering solutions, the Romans would never have been able to conquer half of the then-known world and build the greatest empire of antiquity, which left its mark for millennia to come. Each of these inventions represented a revolutionary step in military affairs. The gladius transformed close combat from a chaotic melee into a precise, methodical science of killing. The pilum destroyed the traditional tactics of shield walls and rendered the defensive formations of enemies meaningless. The scutum gave legionaries reliable protection, turning the infantry into a mobile fortress. The ballista gave the army the ability to wage accurate and powerful long-range combat for the first time. Catapults made it possible to destroy the strongest fortifications and turn sieges from months of torment into relatively quick operations. Castra, standardized field camps, gave the army autonomy and impregnability anywhere in the empire. Finally, the construction of the testudo made the Roman infantry virtually invulnerable to fire and allowed it to storm even the most heavily defended positions. But most importantly, the strength of Roman weapons lay not only in the iron and wood from which they were made. Success was determined by a systematic approach. Each type of weapon complemented the others. Swords worked in conjunction with shields. Pilums paved the way for gladiuses to attack. Siege engines operated under the cover of infantry, and camps provided security and supplies for the army. Together, this formed a complex military machine that was much greater than the sum of its parts. Roman engineers and armorers stood at the intersection of craftsmanship and science. They studied the laws of physics, applied the fundamentals of mathematics and geometry, and experimented with metals and wood. Roman metallurgy and mechanics were the pinnacle of ancient engineering, and their developments became the foundation for subsequent civilizations. Mass production was another secret to their success. While barbarian tribes forged weapons individually, Roman arsenals produced thousands of gladiuses, pilums, and shields, all identical in standard and quality. This unification gave the army uniformity and reliability, which became its hallmark. Weapons training was also based on scientific principles. Legionnaires did not simply learn how to fight, they trained according to strict methods, practicing movements for hours on end, and perfecting their strikes until they became automatic. This transformed simple peasants into true professional warriors who acted as a single organism. The Roman Empire fell not because the Romans forgot how to fight, but because their military technology became obsolete. The barbarians adopted Roman weapons, studied Roman tactics, created their own armies based on the Roman model, and turned the empire's strength against itself. The lesson of Roman military superiority is still relevant today. In the modern world, those who are better at technology, more efficient at organizing production, and better at training personnel are the ones who win. The principles that ensured Roman dominance in the ancient world still work in the 21st century. Which Roman invention do you think was the most revolutionary? Do you think the Romans could have won without technological superiority? What modern military technologies can be compared to Roman ones in terms of their impact on history? Share your thoughts in the comments.